participants here, let's take a look at this question. We solved this question, the same question for exponential Fourier series using the trigonometric method. Now we're going to solve this same question for the same Fourier series, but this time using the exponential method. All right, so the first thing is to find our period. So our period, let's say, is from here to here. Okay, so let's say our period is from here to here. T is equals to 2 pi. Okay, and it's from what? 0 less than t less than what? 2 pi. Okay, that's our period. So in this case, our omega naught, okay, in this case, our omega naught becomes omega naught is equals to 2 pi on t, which is equals to 2 pi on 2 pi, okay, which is equals to 1. Okay, so exponential Fourier series x of t is equals to Cm before I'm going to have summation here, okay, equals to infinity, n is equals to negative infinity, Cm into E j n omega naught t. Okay, so this is a formula for exponential Fourier series. Okay, then I can write my period, okay, which is from 0 to t and then to what? 2 pi. Okay, so this is my period. So for this particular period, okay, if I want to include c naught to this equation, then it will become s of t is equals to c naught plus this, okay, n equals to minus infinity, okay, Cm into Jn omega naught t. Okay, here I can also, instead of writing this period, which is more specific, I can also write the general one, which is t naught less than t, okay, which is less than what? T naught, let's say, plus what? T. Okay, all right. So now here, what I have to do is that I have to find my Cm and my C naught values. Okay, first let's find our Cm values. So Cm is equals to 1 over t into our period. Okay, into our period. So our period is from what? 0 to 2 pi into what? F of t into E minus j n omega naught t. Okay, so this is what we're going to have in this particular instance. Okay, in this particular instance. All right, so now what we can do from here is that we can just introduce our specific values. Okay, our specific values. So I can say that Cm is equals to 1 over 2 pi into 0 to pi. Okay, 0 to pi. Please, this place is a, here is minus a. All right, okay, so we have to introduce those things, and then let's move forward. So now here I have a into E minus Jn omega naught t. Okay, so now if you look at this waveform, you see that 0 to j, the value is a. Sorry, 0 to pi, the value is a. Pi to 2 pi, the value is what? Minus a. So now here I'll have minus 1 over what? 2 pi into what? Pi to what? 2 pi, the value is what? Minus a. That's why I brought the minus here. Okay, into another a, into what? E minus what? Jn omega naught what? T. Okay, I can bring the t here. Here also that you can have the t here. All right, so you can have this equation. Okay, okay, so now proceeding on from here, I can say that Cm is equals to A over 2 pi into 0 to pi into E minus Jn omega naught. What is the value for omega naught? We realize that we found omega naught to be 1. Okay, we found omega naught to be what? 1. Okay, so we're going to use that 1. We're just going to substitute it what? Inside. So now here, if I put 1 into this place, then it's going to be what? Minus Jn what? T. Okay, minus Jn T. Okay, and then what I'm going to have again is that I'm going to have this particular aspect also. Okay, it's going to be what? So let me say what? dt. Okay, minus 1 over what? 2 pi into what? Pi to what? 2 pi. Here is what? A into E minus Jn. Omega naught is 1. So n what? T. dt. Okay, so this is what I am going to have. Alright, so this is what I'm going to have. Okay, please, here, let me write x of t, okay, because normally in the exponential we use x of t, and then in the trigonometry we use f of t just to differentiate them. But I think I'm always writing the f of t because I'm so much used to that one. Okay, so let's proceed on quickly from this particular point where we are. Okay, so in terms of our differentiation, I'm going to have Cm is equals to A over 2 pi. Okay, A over 2 pi. So A over what? 2 pi. So if I integrate this, what do I get? Okay, if I integrate this, I'll get E minus what? J n what? T. Okay, over minus what? Jn. Alright, and then I will have it this way, 0 to what? Pi. Then if I integrate this, what do I get? Okay, I'm going to have A over what? 2 pi into what? E minus what? Jn what? T over what? Minus Jn. But minus will make this one what? Plus, so that I can make here what? Jn. Okay, and then here I can make here pi what? 2 pi. Alright, so this is how I can actually get it to be. Okay, so now moving on from there, what I can say is that I can now put in my limits. Okay, so now we're going to introduce our limits, but like we normally tell you that whenever you are introducing your limit, it is important that you introduce the upper limit first before the what? Lower limit. Okay, so Cm is equals to A over what? 2 pi into E minus Jn. Okay, so whenever I see n, whenever I see t, I'll put pi there. N what? N pi over minus j what? N. Okay, so this one plus E minus j n what? N. What happens is that you put in the upper limit and then what? The lower limit. Okay, the upper limit and the lower limit. Okay, so now if I put in 0, okay, if I put in 0, I'm going to get what? 1. Okay, so please let me rewrite this particular stage again. So Cm is equals to A over 2 pi into the limits that I'm going to place in. So the upper limit first. So if I put in the upper limit, I'm going to get minus, okay, I'm going to get minus into, so this whole thing is minus, okay, so minus E minus J n what? Pi, okay, E minus J n pi, Okay, if e exponent 0, if I put in 0, it's what? It's 1. E exponent 0 is 1. But because it's lower limit, it's going to subtract. So I'm going to get what? 1. Okay. Please, you have to remember where this minus is coming from. Okay. This minus is coming from the negative jn, which was dividing. It was coming from this place as in our previous stage. Okay, so now what I can do is that I can bring that in here. Okay, I can bring that one in here. Okay, and then I can bring that j over here. Okay, all right. So now let's move on from here. Okay, so now that is was putting in the 0 and then the pi. Now let me put in the pi and then the 2 pi. Okay, so the pi and the 2 pi, that I'll have to put in 2 pi first because the 2 pi is my upper limit. So e exponent minus j n 2 pi. Okay, minus j n 2 pi. Okay, minus, okay, e exponent minus j n what? N pi. Okay, so these are what I'm going to have. Okay, this is what I'm going to have. Okay, so now having this one, then we will proceed from this particular stage. So now from this stage, what we can do again is that we have to determine the value for e exponent minus jn, and then e exponent minus jn 2 pi. Okay, so first let's write e exponent minus j n pi. What is this particular term? Okay, so this term is equals to cos what? N pi minus j sine n what? Pi. Okay, so what is the value of this? Okay, we know that the value of sine n pi will always be 0 because if n is 1, sine pi is 0. If n is 2, sine 2 pi is 0. If n is 3, sine 3 pi is 0. And so on and so forth. Okay, so that means that we'll be left with only this one. So we can say that it's equals to what? Cos n what? Pi. Okay, it's equals to cos n pi. And then let's determine the value for e exponent minus j n what? Minus j 2 n what? Pi. It's better to write it this way. Okay, so that is equals to what? Cos 2 pi n. Okay, cos 2 pi n. Okay, minus j sine 2 pi what? N. Okay, so it's equals to this. Okay, so what is this? Okay, we know that what is going to be the value for cos 2 pi n? Okay, cos 2 pi n is going to be 0. Okay, and then what is the value for cos 2 pi cos 2 pi n? Cos 2 pi n will always be 1, because if n is 1, cos 2 pi is 1. If n is 2, cos 4 pi, if n is 2, that'll be cos 4 pi. Cos 4 pi is always what? 1. Okay, if n is 3, cos 6 pi. Cos 6 pi is 1. Okay, if n is 4, cos 4 pi is 1. I think I have shown you this over and over again. Okay, but let me see. Let me just briefly show you again. Okay, so now this is our cos wave. Okay, this is what? Our cos wave. Okay, so the cos wave is always like this. Okay, it's always like this. So here is what? 1. Here is minus what? 1. Here is 0. Okay, here is what? Pi on 2. Here is what? Pi. Here is what? 2 pi. Here is what? 3 pi. Okay, here is what? 4 pi. Here is what? 5 pi. Okay, wait a minute, please. We made a mistake. Okay, I made a mistake. Sorry. It's not like this. Let me redo it again. Let me retake it again. Okay, here is pi on 2. Okay, here is what? Pi. Here is what? 2 pi. Here is what? 3 pi. Here is what? 4 pi. Here is what? 5 pi. Here is what? Here is what? 6 pi. Okay, and then what? 7 pi. So now you see, whenever you have cos pi, it's -1. But cos 2 pi is what? 1. Cos 4 pi is what? 1. Cos 6 pi is what? 1. So here will be what? Cos what? 8 what? Pi. It will also be 1. Okay. So now, here, what will happen is that if I put n to be 1, I'll have cos 2 pi, which is 1. If I put in n to be 2, I'll have cos what? 4 pi, which is 1. If I put in n to be 3, I'll have what? Cos 6 pi, which is also 1. And here, sine 2 pi n is what? 0. So if you don't know that one, let me show you how I can show you that one also. It's also very simple. Okay, it's also very simple. So now here, this is what? The sine wave. Okay, so here is 0. Alright, here is what? Pi on 2. Here is what? Pi. Here is what? 2 pi. Here is what? 3 pi. Here is what? 4 pi. So now we know that sine pi is what? 0. Sine 2 pi is what? 0. 3 pi is what? 0. 4 pi is what? 0. Okay, so similarly, cos, if n is what? 1, cos 2 pi is 0. If n is 2, cos 4 pi is 0. If n is 3, cos what? 6 pi is 0. So 0. So we left with only this one, which is what? 1. So it's equals to 1. Alright, so that is how you can be able to determine this. Now, having known this, okay, having known this one, then you can now proceed further. Okay, so now you can now proceed further by introducing these answers into the limits that you have. Alright, so now I can say that Cm is equals to my Cm is equals to what I have here, A over what? 2 pi n and what? J. Okay, into what I have here. Okay, E minus. Okay, I can put something like this here. Okay, so I can have what? Let's say minus here. Okay, E exponent minus 2 pi what? N. What did I got? I got what? Cos what? N what? Pi minus 1. Okay, I got cos what? N pi minus 1. Alright, so now here, what I can also do here is that I can have this one to be what? 1. Okay, I can have this one to be 1. Minus what? Which is the same thing, as this one, which is what? Cos n pi. Okay, sorry, this one is cos n pi, because here is cos n pi. Okay, minus cos what? N pi. Alright, okay. So now from here, I can just close it. So now here Cm, okay. So now here Cm is equals to okay. Cm is equals to what can I even write here is that I can write A into J 2 pi. I think let's bring our J. J is supposed to be actually down because it was down at the place from the place that we brought it. Okay, J was actually down. Okay, so J was actually down. Okay, so here is what? N. Alright, here is N. So I'm going to have here, if I multiply through, I'm going to have 1 minus cos what? N pi. Okay, plus here is going to be the same. 1 minus what? Cos what? N pi. Okay. Okay, so this is what I'm going to get. Okay, so here there are 2. So I'll have, if I add them, I'm going to have 2a over what? J 2 pi what? N. Okay, into what? 1 minus cos what? N pi. So this is what I am going to what? Get. Okay, so this is what I'm going to get for my Cm. Okay, so knowing this, that I'm going to get this one for my Cm, I can now proceed further. okay, by introducing values into this particular equation. So now I can say that Cm is equals to, let me introduce odd numbers and I'll introduce what? Even numbers, okay? So let's say that here, what I can also do here before I even proceed is that I can cancel out the 2 and I'll have a over what? J pi n into what? 1 minus cos n pi. Okay, so here if n is 1, if n is 1, what is cos pi? Okay, I know that cos pi is what? Minus 1. So here will be what? Minus 1 minus 1. That will be positive what? 2. That is good. So I can move on. If n is what? 2, I'll have what? Cos 2 pi. Cos 2 pi is what? Positive 1. 1 minus 1, the whole thing becomes 0. Okay. If n is, let's say, 3, then I'll have what? Cos 3 pi. Cos 3 pi is what? Minus what? 1. Okay. Minus 1 minus 1, that will be 2. And I can multiply here, they become 2. The whole thing can go on. If here is n is 4, I'll have what? Cos 4 pi. Cos 4 pi is what? Positive 1. 1 minus 1, the whole thing will go to 0. So you see that Cm equals what? 0 for what? Even numbers. For n equals what? 2, 4, 6, okay, and on and on and on. Okay, so, but I could see that Cm is equals to what? 2, okay, or is equals to what? A on J pi what? N into what? Into 1 minus what? 1, okay, which is equals to what? Sorry, 1 minus what? 1, which is equals to what? 2a on what? Sorry, let me write it again. Which is equals to, so here, which is equals to what? A on J pi n into what? 2. So now Cm is equals to what? 2a on what? J pi n, which is equals to minus j what? A in terms of complex numbers over what? Pi n. Okay, so basically this is what you get for what? For your Cm. Okay, so I can say this is what? My Cm. Okay, all right. So now let me also determine my what? C naught. Okay, I can also determine my C naught. Okay, so now determining my C naught, what I can say is that C naught basically is 1 over what? Here I have to put the condition that for what? For n equals to what? 1, 3, 5, on and on and on. Okay, and then n is not equals to what? 0. Because if n is 0, you have what? 2a over what? J pi what? N. If n is 0, any number divided by 0 goes to what? Infinity. The whole thing will go to infinity. So it will not be what? Defined. So n cannot be equal to 0. So specifically, let me find for the what? For the 0. That is called the what? The C naught. So the C naught is 1 over t integral what? T naught plus what? T, okay, into f of what? T, okay, dt. Okay, so this is equals to what? 1 over what? 2 pi into what? Into 0 to what? 0 to 2 pi, okay, into what? F of t, okay, so what is f of t here? F of t, dt. So this one, I have to break it into 2, which will be what? 2 pi into 0 to what? 0 to pi, okay, 0 to pi into a, okay, a what? dt minus what? 1 over what? 2 pi, okay, into what? Pi to what? 2 pi, because you can see from the wave, the signal we have, that here is what? Positive, here is what? Negative, okay, that is why I have here to be what? Positive, here to be what? Negative, all right. So now here, what I can say is that a into what? dt, okay, so C naught is equals to 1 over what? 2 pi into what? 0 to pi into what? I can bring the a out so that I can have what? The t minus what? A over what? 2 pi into what? 0 to what? No, into what? Pi to what? 2 pi into what? The t. So this is equals to what? So this will be equals what? A over what? 2 pi out. Okay, a over 2 pi out. Here, if you actually integrate, you get what? T. You get t. And if you put in your limit, that means that you get what? Pi minus what? 0. Okay, you get pi minus 0. All right, and then here you're going to get minus what? The same t. If you put in your limits, you get what? 2 pi minus what? Pi. Okay. Okay. So this is what you're going to get. All right. So this one is equals to what? A on what? 2 pi. Okay. Into what? You get what? Pi minus what? Pi. You get what? Pi minus what? Pi. Okay. So in the nutshell, you get what? C naught to be equals to what? A over what? 2 pi into what? 0, which is equals to what? 0. Okay, and that is what? Very understandable. Why is that very understandable? Because if you look at your waveform, here is what? Negative is equals to positive. Positive equals to negative. Negative equals to positive. Positive equals to what? Negative. Which is equals to what? This positive. Okay, so everything will cancel out because negative will cancel positive. Positive will cancel negative. Negative will cancel positive. Positive will cancel negative. Negative will cancel positive. Everything will go out. Okay, so that's how you do it. Okay, so now, if you are writing your overall equation, so now your overall equation will now become, as x of what? T is equals to what? C naught plus what? Summation up to what? Infinity. N is equals to minus what? Infinity. Here, Cm into what? E into what? N, E into what? N. Here is what? J. Omega naught what? T. Okay, for what? For your interval, which is what? T naught less than what? T less than what? T naught plus T. But instead of writing plus T, you can put in the formula. What is the formula for plus T? The formula for plus T is what? 2 pi over what? Omega naught. Okay, so you can just put in your formula. Okay, so now here, x of t is equals to here. A naught is what? 0 plus what? Summation up to what? Infinity. From negative infinity. Okay, what is Cm? Okay, so what did we get for Cm? What we got for Cm was what? 2a over what? J pi n or n pi, which is what? The same. Okay, so here I can write what? What I got over there. Okay, and what I got over there was what? 2a over what? J what? Pi n. Okay, and then is times what? The complex aspect, which is J n omega naught is 1. Okay, so n what? T. Okay, so basically this is what I got. Okay, you can just leave your formula in this way. So if you eliminate your 0, then you're going to have exponent what? This n equals to minus what? This into what? 2a over what? J pi what? N into what? E into what? J n what? T. Okay, so this is what you get for your what? For your x of what? T. Okay, for your x of t. So now, moving on from here, always here we have to draw our what? Our frequency spectrum. And our frequency spectrum is the amplitude versus what? The frequency. Okay, the amplitude versus the frequency. And we always use the what? The Cm value. In other book, they will say what? Cn, but Cn and Cm are the same. And or they can use what? Any value at all. So here, frequency what? Spectrum. Okay, so what is that frequency spectrum? It's what? Cn, or here Cm versus what? Versus what? N omega naught. N omega naught is the frequency. Okay, yeah, so N omega naught is the frequency. So here, let's say C1. What is C1? Okay, so C1, like I said, it can be what? If you bring the J upward, then it becomes negative what? 2a. Okay, over what? If over pi. Why is it now over pi? Why am I not writing over what? N pi? Because now n is what? 1. Okay, because now n is 1. So now if n is what? Minus 1, then I will have what? positive j, because negative will now become what? Positive over what? Pi. Now let me take the modulus of this. So if I take the modulus of this, then I have what? C1, which is what? Becomes what? Positive. Okay, if I take the modulus over what? Pi. Okay, I'm so sorry. If I take the modulus, I'm so sorry. There will be no j. Okay, if I take the modulus, C1 is equals to what? 2a over what? Pi. And here it will become what? Negative C1 modulus. Okay, the j will disappear. And then it will become what? 2a over what? Pi. Now let me take what? C2. If I take C2, I'll have what? Minus j 2a over what? 2 pi. Okay, over 2 pi. Okay, but you realize that why should I take 2? I don't really have to take 2. Why shouldn't I take 2? Because you realize that when we went through our procedure, you see that Cm was equals to what? 0 for what? For even numbers. Okay, I told you that Cm is equal to what? 0 for even numbers. So if Cm is equal to 0 for even numbers, that means that even numbers are not included in this particular what? Fourier expansion values that we're supposed to what? Get. Okay, so I don't have to include even numbers in my spectrum. Okay, so I'll remove what? C2 and I'll make it what? C3. Okay, so minus 2ja over what? 3 pi. Okay, and here C3 what? Negative. It will equals what? J2a over what? 3 pi. Okay, and then if I take the modulus, C3 okay is equals to what? 2a over what? 3 pi. And here if I take the modulus minus C3, the modulus, I'll get what? 2a over what? 3 pi. Okay, if I take what? If I take what again can I, if I take C5, okay, sorry you were not seeing at that time, sorry, I didn't notice. So here C5, so C5 is equals to what? It's going to be minus what? J2a over what? 5 pi. And then C5 minus, okay, C5 minus, okay, so C minus 5 is equals to what? 2a, here is positive, okay, J2a over what? 5 pi. So if I take the modulus C5, okay, modulus is equals to what? 2a over what? 5 pi. If I take the modulus here, minus C5, okay, the modulus here is what? 2a over what? 5 pi. Alright, so it goes what? On and on and on and on. So we can stop at this particular point. So now when we stop here, then what we would do is to realize our what? Frequency spectrum, okay? To realize our frequency spectrum. So the frequency spectrum, I told you that is what? Your Cm, okay, modulus, okay, versus what? Your n omega naught. So I'll put here what? N omega naught, okay, and then here is my what? 0. Okay, here is my 0. 0, which is what? My Cm modulus. Okay, so now here I had what? 1, and then I had what? From 1 you go to what? 2, and then you go to what? 3, you go to what? 4, you go to what? 5. Okay, and you go to 5. So let's stop at 5. So here's 1, 2, 3, 4, 5. So here 1, 2, 3, 4, 5. Okay, so here 1, 2, 3, 4, and 5. So here 1. What did I get for 1? 1. You remember that I got what? 2a over what? Pi, which is bigger, which is the longest amplitude. 2a over what? Pi. Okay, and here I got the next longest. Okay, which is what? 2a over what? 3 pi. And here I got the shortest, which is what? 2a over what? 5 pi. Why am I not doing anything here? Because I told you that the signal was defined for what? 0 for even numbers. So C2 is 0, C4 is 0. And it's going to be the same thing at the what? At this side also. Okay, so here I'll get what? 2a over what? 5 pi. Here I'll get what? I'll get the middle one, which is what? 2a over what? 3 pi. 3 pi. Sorry, here is not 5 pi, it's 2a over what? Pi. Sorry, it's 2a over pi. And in this one, okay, which is what? 2a over what? 5 pi. Okay, students, so this will be the end of this particular question. Thank you so much and see you in the next class. Thank you.